2.6. Solving equations using multiplication or division. In this lesson, we'll learn how to use the division property of equality and the multiplication property of equality to solve equations. So in words, when you're dividing each side of an equation by the same non-zero number, it will produce an equivalent equation. So for example, if 3x equals to 12, and I would like to isolate the variable x, all I have to do is take the coefficient 3 and divide that to both sides of the equation. So as you can see, we have divide by 3, divide by 3. And then we cancel out the 3 to get x on one side, and this will be equal to 12 divided by 3, which equals to 4. So if I were to work this out vertically, 3x equals to 12. Okay. And for the multiplication property of equality in words, you will multiply each side of an equation by the same non-zero number, and this will also produce an equivalent equation. So if we look at this numerical example, if x over 3 equals to 12, then to solve for the variable x, I need to take the reciprocal of 1 over 3, which is 3, and multiply 3 to both sides of the equation. I could cancel out the 3 to get x isolated to one side of an equation, and then I can multiply 3 and 12 to get 36. So vertically, cancel, x equals to 36. Guided practice. I'm going to use part A to review what we're doing here. Division and multiplication are inverse operations that undo each other. When you use the same inverse operation on each side of an equation, you produce equivalent equations which have the same solutions. Therefore, in part B, you can solve these equations by applying the two properties above. So for the first one, 54 equals 9x, I can divide both sides by 9. (54) divided by 9 gives me 6. And for 5c equals negative 15, cancel out the 5, c would give me negative 3. And for this one, 6 equals to u over 4. To isolate the variable u, I will need to multiply both sides by the reciprocal of 1 over 4. Cancel out the 4. 4 times 6 would equal to 24. And the same thing for the next one. Let's take a look at some word problems. Here, I have the chart for you again for solving word problems. You need to first plan, solve neatly, and then check. Let's take a look at a problem that involves rate. And the formula we would use is D equals RT. On January 4, 2003, the SOHO spacecraft detected solar wind traveling at about 2 million kilometers per hour. So in this first sentence, it already tells you what the paragraph is about. And it also gives you a piece of information that you will need to solve the word problem, which is the rate. The sun is about 150 million kilometers from Earth. So sun, Earth. So it gives you the distance here. 150 million km. About how long did it take the solar wind to reach Earth? So again, distance equals rate times time, and we're looking for the time. So let t equals the time. Distance, which is 150 million. We can sub that in. So there's 6 zeros after 150. Rate is 2 million kilometers per hour. And times t. And we can cancel out the 6 0, and 150 divided by 2 would give you 75. Therefore, it's 75 hours. Drilling. One type of thermal ice drill can drill through ice at a rate of 15 feet per minute. Again, this word problem, in the first sentence, it tells you what it's about and also gives you a piece of information you'll need to solve the word problem. So a drill is a machine that can drill ice. Okay, and it's able to drill ice at a rate of 15 feet per minute. Find the time it takes the drill to melt through the sheet of ice 75 feet thick. So 75 represents our length here. You can again use distance equals rate times time, but distance here is more like length, or how deep. Okay, so we have 75 equals 15t, and then after you solve for t, it should be 5. Since you divided both sides by 15, cancel out the 15, 75 divided by 15 is 5. And that would be 5 minutes. And that concludes our lesson.